All right. So the story so far, look at this all of you. The story so far is we have the input layer which has input images. We have the convolution layer. Convolution layer is created by applying multiple filters. These filters detect the features. We apply multiple filters. We'll apply multiple convoluted images. That is what happens in the convolution. Then we add a pooling layer. In pooling layer, what happens? Once again, tell me. In pooling layer, what happens? Pooling layer, convolution layer, I know particular features will be highlighted. What happens in the pooling layer? In the pooling layer, nothing special happens. It will just size will be reduced. Size will be reduced so that you can execute the algorithm much faster. Pooling layer simply reduces the size only. You know what happens? We have the input image, input layer, which is input layer. Then we have the convolution layer, pooling layer, right? Then we add one more convolution layer, one more pooling layer, one more convolution layer, one more pooling layer. That is how it is done usually. This convolution layer is to detect the low level features. Then add a pooling layer right after that. In reality, that's what we do. In the example that we are going to try also, we are going to do that. Then we add one more convolution layer to detect what? Can you help me thinking about it? Then we add one more convolution layer. This will detect what? This is detecting low level features. Imagine all the small shapes like straight lines or this curve, that curve, or these kind of circles or sharp edges, L curves and all that. This convolution layer, next layer will detect the mid-level features. Can you make a guess about mid-level features? What are the mid-level features? A combination of low-level features will form the mid-level features. Okay. Then one more convolution layer that will detect the high level features, pooling layer, etc, etc. Once all the features are detected, then you know what? Then you can simply follow the ANN approach because you have already detected the features. Now you can flatten it if you want to. Now you can make it like a straight line since already features are detected, then classification can be done. Okay. So until now we have ANN which has input layer, hidden layer, output layer. But CNN is different. Input layer, convolution layer, pooling layer, convolution layer 2, pooling layer, convolution layer 3, pooling layer, convolution layer 4, if required, pooling layer. Finally, you know what do? We come back to the basics. Fully connected hidden layer, we'll add it. Basically, we can make it look like an ANN only finally. Now there is no problem. Once you have the convolution pooling done, there is no problem. You can now flatten it. Flattening means make it look like an array. Make it look like a single array. Then you can connect it to the output layer. Classification will be done. So here is the final CNN architecture. Input layer followed by convolution layer, pooling layer. In reality, what happens is one more convolution layer, one more pooling layer, one more one more pooling, all this done. Once it is done, you have the fully connected output, fully connected hidden layer, usual hidden layer, that is the dense layer that we talk about. Then it is connected to output layer. In the output, you have those classes, cat versus car versus your car versus road versus tree. All these classes are there in the output. So we take the image, you have the convoluted layer. Now you can understand. Can you tell me why it is represented like this, anybody? And what does this mean? Can somebody tell me why there is a diagram that is going from here to here and one value here, and then why, let's say 1 2 3 4 5? What does this 5 mean? Why it is represented like this? Can somebody tell me that? Can somebody understand this diagram? This is the input layer. Okay, input layer. Yes, what is happening here? Why there are 5 here? These are the 5 layers, or can I say these are the 5 convolution layers, or this is a single convolution layer with 5 filters? Which one is correct? Can I say these are the 5 convolution layers, or this is a single convolution layer with 5 filters? Which statement is correct? This is single convolution layer with 5 filters, and the subregion of this will end up like a pixel here. Again, there is one subregion that will ending up like a pixel here. Can you tell me why the image is slightly bigger here? Why the image is slightly bigger here? Why the box is bigger here? Why the box is smaller here? Can somebody tell me that? Why there is a difference in the box? Why there is a size difference? Was it just randomly, just by chance they kept it, or something else was done in between? Was it shown there somewhere? Was it shown there? Was it given from here to here? There is something has been done. Yes, max pooling has been done. Can you see the difference? Now, after max pooling, again convolution was applied. How many filters were applied in conv 2? Here, this is conv 1. This is convolution layer 2. In conv 2, how many filters were applied? 1, 2, 3, 4, 5 again. And what about this one? VAC. What is this VAC? Can you tell me what is this VAC is all about? This is like convolution layer 1, convolution layer 2, low level, mid level are sufficient for the type of data. It depends on the data. What about this VAC? All about? What is this thing? What is this one? Hidden layer. This is our usual hidden layer. If you want to make it as a hidden layer, you take this data, convert it into kind of one vector or an array, and then connect it to the output layer. This is the output layer. These are different layers in convolutional neural network. Until now, we discussed only theory. Let us reconnect all this by taking one example and the code and see how these are mentioned, how pooling is mentioned. All these details we will see with an example. Not only with one example, we will try to do it with two examples. First, I will take a relatively simple example. Later, we will take a very much complex example. In this one, we'll understand the coding terminology. We'll understand the syntax. In the next one, we'll understand the logic of building the CNN models. There is a data set called Canadian Institute for Advanced Research, known as CFAR dataset. It is a collection of large number of images. The dataset that we are taking here is CFAR 10 dataset. It contains 60,000 images, which are 32 by 32 color images. So what will be the shape of the image? When somebody says 32 by 32 color, can you tell me what will be the shape then? 32 by 32 by 3. We have to write it like that, isn't it? It is mandatory because color images have depth. My input data has depth. And 10 different classes are there in the output. These images have aeroplanes, cars, birds, cats, deer, dogs, frogs, horses, ships, and trucks. Out of these 60,000, maybe 10,000 aeroplanes are there, 10,000 cars are there. I think 6,000 cars, 6,000 birds, 6,000 cats, frogs, horses, ships, and trucks. Usually, we have to get this data originally. First, we will take the direct numerical data. In the next example, we will directly take images only. We don't even take the numerical data. Here, we already have the numerical data available for us. Let us go to the code. In the Keras datasets, CFAR data is already available. We load the data. And what does this mean? We discussed this earlier. What does this mean? Divided by 255, divided by 255. Train images divided by 255. Test images divided by 255. I took the images and then I divided them by 255. Did we discuss that? It is called scaling or normalizing. Normalizing means bringing everything between 0 and 1. Maximum value of a pixel value is 255. I'm dividing it with 255. These are the final class names: aeroplanes, mobiles, birds, cat, deer, and all that. These are some of the example images. 32 by 32 means very highly pixelated values will be there. Very, very small images. These are frogs, trucks, cars. Since these are very pixelated, we cannot expect 100% accuracy. Maybe very less accuracy will come because the model accuracy depends on the input data. Do you agree with that point? No matter What great technique you have, any model, any machine learning model or deep learning model in this world is as good as the data that you give. So depending on input data only, our model accuracy will depend on that. This is the data. Once the data is ready, once you can see the images, give me a confirmation. I have to explain this code one by one, parameter by parameter, in depth. So once you have the input data and once you can see the images, let me know. I'll explain you the code right now. Okay, all of you done? Perfect. Ready? I'll tell you one usual trick that people follow. By default, there will be always 3 layers of convolution. Always. You follow this trick, you will also build a good model. Convolution layer 1, usually what is it used for? We are thinking that convolution layer 1 is used for detecting the low level features, layer 2 mid level features, layer 3 high level features. Yes or no? Then you had the hidden layer. This is conv1, this is conv2, this is conv3, then one hidden layer, then one output layer. Yes or no? Right after convolution layer, as a practice, what do we do to keep the data size low or at a manageable value? What do we do? Right after adding the convolution layer, what do we do? Usually, what is the practice? Pooling layer. Pooling. Pooling, what is the standard that we do? We don't need to think a lot about pooling. What is the standard pooling? 2 cross 2 with stride 2, max pooling. Yeah, 2 cross 2, max stride 2, don't worry about it. Conv 2 pooling, conv 2 pooling. Okay, conv 3 pooling, then the hidden. After hidden, you don't need pooling, directly connected to the output layer. Are you with me, everyone? Hmm? Okay, let us start writing the code for this one. Model, the usual Keras one only, models dot sequential. Okay, model equal to model dot. So let us add our first convolution layer, model dot add. Earlier we used to add dense layers, but now it is convolution layer, layers dot conv 2D. You understand what is conv 2D, isn't it? Conv 2D means you are moving in the rows and columns while applying the filter. Okay, after that you mention the kernel size. First of all, how many filters are there, how many filters, and the filter size or the kernel size, how many kernels and the kernel size. I'm saying kernel size is 3 by 3 because our input data is 32 by 32. I think kernel size 3 by 3 should be good enough. Even if you try 5 by 5 also, not a problem. Then you mention the activation function, then you mention the input shape. Input shape only first time you have to mention. Okay, look at these details. Model equal to models dot sequential, model dot add convolution 16 comma 3 comma 3. First of all, tell me what is 16 here. What is 16 here? What is 16? 16 is number of filters in convolution layer 1. How do I know 16 is the right number or wrong number? We don't really know. But you know what? Listen to me carefully. The basic shapes, if you really zoom in, very much zoom into any image, very much zoom into any image, the basic shapes are these only. In any, if you take any image in this world, don't you think these are the basic shapes that you get? Basic geometrical shapes, they are very much limited. The smallest type of shapes that you will get, they are very much limited in reality. So the basic shapes are these only. I'm thinking 16 is sufficient. That is why I gave, there are 16 low level features. Low level features means basic shapes. 3 cross 3 is the kernel matrix. Activation equal to ReLU. Can somebody tell me why I am picking ReLU here specifically? Why not sigmoid? Why not tanh? What is the speciality of ReLU? What is the speciality of ReLU? ReLU activation. What is its speciality? ReLU activation speciality is the issue with sigmoid and tanh is when the network is very much deep in nature, very, very deep, then you will have an issue. What is the issue? The issue of vanishing gradients. You will have the issue of vanishing gradients. And CNN by default is very deep. You will have definitely one convolution layer, pooling layer, convolution, pooling, convolution, pooling. These six will be there, and there will be one hidden layer for sure. These are the convolution neural networks are by default deep in nature. To keep the gradient alive, we have to use ReLU. So when you are using CNN by default, without any doubt, you will be using ReLU only. By default, you will be using ReLU activation. Okay. Input shape is 32 by 32 by 3. Max pooling 2 cross 2. Then model dot add layers conv 2D. What about 32 now? Tell me what is 32 here? What is 32 here? The number 32 here is number of filters. Usually you have to increase this way. So this is low level features. Mid level features, how mid level features are formed? A combination of low level features. A combination of low level features will form the mid level features. Do you agree with that point? A combination of low level features will give you the mid level features. So obviously, if you take these 16 features and if you combine them, different shapes will be formed. Obviously, we have to give a higher number. Mid-level features are always higher because these combinations, multiple combinations can be made based on the low-level features. That is why if you are giving 16 here, experts suggest that you give 32 here. If you are giving 8 here, you give 16 here, like that. 3 cross 3 is the shape. Activation is ReLU. Conv2 second one is done for detecting the mid-level features. Done. Add the pooling layer. Again, a combination of mid-level features will give you the high-level features. You combine mid-level features, will give you the high-level features, the real shapes and all that. That is why if you have 32 filters here, you add 64 filters here. 64 filters, a combination of mid-level feature. Kernel size is 3 cross 3. Activation ReLU. This is for high-level features. Always give higher than the model.add max pooling time. Flatten it because we are now ready to build the ANN. We are now ready to add the dense layer. If you want to add a dense layer, now this is like 64 or this is having height and width. Dense layers cannot connect to that one. You flatten it. Flattening means, let's say if it is 16 by 16, by flattening we mean to say you make it like 256 in one array style. So you make it like one array. That is what the flattening is. And then you add final dense layer with 64 nodes, and then the final output layer. Output layer has 10 nodes. Activation ReLU, 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 ReLU. Important point. ReLU is the activation by default that you use in most of the deep neural networks, image processing. That is how the layers workflow is. Input layer, con pooling, fully connected hidden layer, and the final output layer. Okay, that is what is this model all about, and this is the summary. Look at the number of parameters, 40,000 only, not going into millions. Once everything is ready, we will try to compile the model. Optimizer Adam. Adam is another alternative to SGD, stochastic gradient descent. Adam is another type of optimizer. We can use SGD as well. Running to epochs. Okay. Once you run to epochs, you can save the model, model.save weights. You can load the model and then execute further epochs. Or Somebody else has already executed the model with the same configuration, which I have done in my case. If you already have the model, you get the model file, import the weights from the saved model, then you execute on top of it. That is how CNN model is built. Here I am trying to explain this particular piece of code. I'll tell you one of the most widely done mistake by amateur deep learning enthusiasts. What they do is, okay, I want to build a convolution layer, 20 here, 20 here, 20 here. That is one of the biggest mistake that a lot of people do. Con 1 20, con 2 20, con 3 20. That doesn't work. Maybe if you're lucky, it'll work as well. The reason is we have to understand how images are classified. We have to understand this is low level, less features will be there. Mid level, a combination of low level. High level, a combination of them. And you understand why I'm going with 16, 32, 64. I could have easily done like 20, 40, 80, something like that. I could have easily done like that, isn't it? But we discussed we have to not think in decimal system, we have to think in binary system. So here, when we have built that final model, it is giving us somewhere around the accuracy of how much, 60% or something. Okay, it all depends on the input data. This is just to explain you how CNN works. Later on, we will take some real images and then try to build our model on this. Go ahead, execute this, all of you. Right? Perfect. There is one standard CNN project assignment that will happen every year. There is something called ImageNet Project Challenge. ImageNet is a large visual database designed to use visual object recognition in software research. More than 14 million images have been annotated. Hand annotation means you have the image, then somebody has told manually that this image is balloon, this image is strawberry, this image is a pen, this image contains a laptop, this image contains a water bottle, this image contains a monitor, like that. Okay, so there are nearly 14 million images. What is this competition all about? Every year the scientists around the world, data scientists around the world, they will be building, or they will be coming up with new convolution neural networks or new image processing algorithms. How do I know the new one is better than the existing one? There has to be a benchmark. Now this is that benchmark. Let's say already there is 90% accuracy by one algorithm. CNN algorithm is giving me 90% accuracy, one of the architecture. If somebody tells that I have a better algorithm, I have a better architecture, I have changed the number of kernels, I have changed the number of filters, etc., etc., how do I know that is better than this? You apply the same CNN on this project. If you give me more accuracy, then only that will be announced as the winner of that year ImageNet project. Okay, so there are some standard networks, CNN networks, that can be that have won that competition. We can also use them. They are actually publicly available. Okay, so there are so many categories, 20,000 categories. Nearly what do we see in our regular life? All those were there, starting from balloons to strawberries to everything is already there. Okay, aeroplanes, cars, trees, animals, rats, everything is there. Okay, AlexNet is one such network. AlexNet is the name of the CNN, which completed the ImageNet challenge in 2012, roughly 8 years back. This has achieved a very good accuracy. Okay, it was designed by Alex Krasowski, Jeffrey Hinton, Ilya Sutskever. So Jeffrey Hinton is known as father of artificial intelligence. The term deep learning was first introduced by Jeffrey Hinton only. He now works in Google. Okay, all these guys put together, they have created AlexNet. Okay, AlexNet contains 8 layers. First 5 are convolution layer, followed by fully connected layers. So they have created one good CNN convolutional network, and it has won the ImageNet challenge. Maybe it's a good idea to understand. Uh, we cannot really build such big AlexNet on such large data set. At least we can understand their architecture. How did they build it? Okay. So here is the architecture of AlexNet. As I told you, since convolution neural networks have depth, because convolution layer has depth, we need to draw 3D diagrams. Okay. Let us understand this AlexNet. So here it is written as 3. This is input layer. Input layer. 3, 224, 224. Can somebody explain me what does 224 by 224 by 3 mean? This is the input image. Tell me, what does that mean? What do you understand from there? What do you understand from there? So this is the input image. Image has height, width, and depth. Depth 3 means what? What are these depth 3 mean? Depth 3 means it is RGB intensity depth. Depth 3 means RGB intensity. Okay, that is the depth. Now here it shows 11 cross 11. That is giving us 1 pixel in the next layer. What does that mean? 11 cross 11 is giving us 1 pixel in the next layer. That means the filter size, the kernel matrix size. What is the kernel matrix size here? On the first convolution layer, the kernel matrix size is 11 cross 11. That is the kernel matrix size. And how many such kernel matrices, how many such filters have been applied in convolution layer 1? In convolution layer 1, how many such filters are applied? Every filter will end up like 1 1. So depth of the convolution layer 96. Depth of the convolution layer is 96. That means 11 by 11 filters, there are 96 such filters applied. That is the reason why the convolution layer depth is 96 here. All of you, are you with me? 96 is the depth. 96 filters are applied. Okay. So like depth is shown here, right? Depth 3 RGB. Here depth is 96 because 96 such filters are applied. That is what they mean to say when they write this diagram. Okay. Stride is 4. What do you mean by stride 4? Earlier we move 1 position, right? We skip only 1 pixel when we are moving the filter. If you skip 2 pixels, then size will be 1 by 2. If you skip 3 pixels, that means after moving from 1, you directly go to 4th pixel. After 4, you directly go to 7th pixel. Then the size will be 1/3. If you move with stride 4, the size will be 1/4. Since the stride is 4 here, after applying a filter here, then we skip 4 and then we go to the 5th one. That is the reason why the input image size is 224. The stride are 4. So overall the resultant image shape will be what? Resultant image shape is roughly around 55 or 54. That is the resultant image shape. Let me explain once again. 11 by 11 is the filter size. Filter size is 11 by 11. How many filters? 96. Stride 4. That is the reason why 224 has become 55. 224 has become 55. That is at about the first convolution layer. Okay. After the first convolution layer, pooling has been applied. Pooling is not shown as a layer. Not shown. Pooling is not shown as a layer. Pooling is just assumed to be, that's it. Like if we simply write it here, that is the standard. Do you remember what happens when you apply pooling? Let's say my size right now is 55 by 55. Once I apply pooling, do you know what will happen? Max pooling has been applied. What will happen? Usually, once you apply pooling, pooling reduces the size. Pooling totally reduces the size. Usually, pooling makes this half. That is the reason why, though it is not shown here, the images are already 20, 55 by 2, which means 27 odd will be the resultant after pooling, but that is not shown here. Okay. After that, after applying that pooling, there is one more convolution layer that has been applied. Now you need to help me. So pooling is done. Okay, pooling now is not shown as a layer. After that, there is one more convolution layer that has been applied. Can you tell me convolution layer 2? What is the filter size first? What is the filter size? Answer this question first. What is the filter size? Convolution layer 2. What is the filter size? Is it shown there? Is it already shown there? Filter size? Can you make a guess, all of you? It is 5 cross 5 filter size, kernel matrix size. How many such filters are applied? How many such filters layer 2? Earlier in convolution layer 1, were there. Two. How many such filters were applied? That will give us the depth of convolution layer. 256 such filters are applied. 256. All right. Understood, everyone? Now, max pooling. What happens to max pooling if I apply 27 by 27? If I apply max pooling on top of it, what will happen? If I apply 27 by 27, if I take 27 by 27 and then max pooling is done, size will be almost half, either 14 or 13. 13. After that, what is the next layer that has been done? What is the next layer that has been added by this team in AlexNet? What is the next layer? Convolution layer 3. Layer 3. Let's talk about layer 3. Can you tell me the filter size, filter matrix size, filter kernel matrix size of layer 3? I think all of you are now getting used to this. Yeah. 3 cross 3. How many filters? How many such filters? How many such filters? How many such filters? 384. Do you see this? I have copied that trick from here only. Start with smaller, almost double, almost double. Do you see this? From low level to mid level to high level, almost doubled, isn't it? After this, are there any pooling that is done? Is there any pooling that is done? After this convolution layer, is there any pooling? No pooling. Now tell me why there is a 55 to 27 here because of pooling. From 27 to 13 because of pooling. Why is again 13 only here? Why it is 13 here? From 13 to 13, why it is not 13 to 7 here? Why there is no 13 to 7 here? Because there is no pooling here. That's why size has not reduced. So after convolution layer 3, directly we are going to convolution layer 4. Now can you completely tell me every detail about convolution layer 4? This is con 1, con 2, con 3, done. This is convolution layer 4. Can you tell me complete details of this convolution layer 4? What is the kernel matrix size? 3 by 3 is the kernel matrix size. Perfect. How many such kernel matrices? How many such filters? 384. Perfect. No doubt about it. Awesome. Yeah. Again, convolution layer 4, convolution layer 5, the last one. Convolution layer 5, last of the convolution. Can you give me complete details of this? Convolution layer 5. Convolution layer 5. Last one. This is convolution layer 5. Details of this. This convolution layer is a resultant of applying 3 cross 3 kernel, 3 cross 3 filter matrix. How many such filters? 256. That's it. These are all the details of these convolutions. After this, what did we do? Finally, did we directly connect it to output layer? No, we added 4096 hidden nodes, dense nodes. Hidden nodes are also known as dense nodes, 4096 dense nodes. That is how this whole AlexNet is built. If when we go to their paper, we will see all these explanations. Whatever we have done here, exactly the same thing will be explained in depth. This is known as AlexNet. Even when you are drawing convolution neural networks, you are supposed to explain, or you have to draw the architecture diagram like this. This is the standard. Pooling is not shown. However, convolution along with the depth is shown like this. It is not as easy as drawing input layer and nodes, hidden layer and nodes, output layer and nodes. It's not that easy because there is a depth associated with each convolution layer here.